and welcome to another video. Here is a question in which our task is to prove that in triangle ABC, b squared parenthesis cot A plus cot B equals c squared parenthesis cot A plus cot C. Now, to be able to prove this identity, we can use about 4 to 5 different methods, to prove this identity. So I'm going to use one of the simplest method. All right, but first we need to establish that the left-hand side equals the right-hand side. So we have that the left-hand side equals right-hand side. So this is the left-hand side. So left-hand side equals b squared parenthesis cot A plus cot B. Okay, so we start with the left-hand side. So when we're done with the left-hand side, then we go to the what? Right-hand side, and then we still do the same thing, and then we can now see if both are equal. All right, so in this case, let's recall the definition for cotangent. Okay, recall the definition for cotangent. So we know that cot A, okay, will be cos A divided by sine A. Then for cot B will be cos B divided by sine B. And also we have cot C. This one will be equals to cos C divided by sine C. Now we can substitute cos A divided by sine A for cot A, cos B divided by sine B for cot B, so that we can have b squared parenthesis cos A divided by sine A plus cos B divided by sine B. Okay, now this is where we can now perform what we call algebraic multiplication. That is, to simplify this, okay, first write b squared parenthesis cos A multiplied by sine B. That will be cos A sine B plus sine A multiplied by cos B. That will be sine A cos B all over sine A multiplied by sine B. That will be sine A sine B. Okay, now again, let's also recall from sum to product property for sine. We know that from sum to product identity for sine A plus B. Now we have that sine A plus B equals sine A, okay, cos B plus cos A sine B. So which means cos A sine B, which is this, plus sine A cos B will be equals sine A plus B. So I'm going to write this to be b squared parenthesis sine A plus B divided by sine A sine B. Now let's now write this B in terms of sine B, okay, using the sine rule. Okay, now applying the sine rule, okay, applying the sine rule and expressing B in terms of sine B. We know that according to sine rule, we have sine, that's A divided by sine A equals B divided by sine B equals C divided by sine C. That will be equals to 2R. So which means if I bring out the fraction B divided by sine B and make that equals to 2R, which is a constant in this case, okay, then B will be equals to 2R sine B. That is when we express B in terms of what? Sine B. So this is B in terms of sine B. Okay, so which means I'm going to substitute 2R sine B for B in this expression. Okay, so now we have, so for B squared, okay, we're going to have 2R sine B raised to the power of 2. That will be B squared because B equals 2R sine B. So raised to the power of 2. That will be 2R sine B raised to the power of 2. Then parentheses. Now we have sine A plus B divided by sine A sine B. Okay, so this will be 4R squared sine squared B parentheses sine A plus B divided by sine A sine B. Sine A sine B. Okay, now also let's not forget that if we use angle sum property, because we are given a triangle, we are given a triangle ABC. We are given a triangle ABC. Triangle ABC. So if we apply angle sum property, that is angle A plus angle B plus angle C, that will be equals to 180. So let me solve for AB. So we have that AB, that is A plus B, will be equals to 180 minus C. So which means sine A plus B will be equals to sine 180 minus C, okay, which is equals to sine C, okay, sine C. Okay, so this will be 4R squared sine squared B parentheses sine C, because sine A plus B equals sine C, divide by sine A sine B. So now sine squared B divided by sine B, that will reduce to sine B. Okay, that is, we're going to have sine B here. So we have 4R squared sine B multiplied by sine C divided by sine A. So we have our left hand side to be equals, left hand side equals 4R squared sine B sine C divided by sine A. So this is the left hand side. Okay, now are we going to get the same identity for the right hand side? Let's find out. So the right hand side equals, we have C squared parentheses cot A plus cot C. Cot A plus cot C. Now again, we're going to what? Use the definition for cotangent. Okay, same way we did here. Okay, so this will be C squared parentheses cos A divided by sine A plus cos C divided by sine C. Now let's again simplify this. Let's simplify. So this will be simplified to be, we have C squared parentheses cos A multiplied by sine C. This will be cos A sine C plus sine A multiplied by cos C plus sine A cos C divided by sine A multiplied by sine C. This will be sine A sine C. Okay, now we can also reduce this to the sum to product identity for the sum of two different angles A and C. That is, now let's recall the sum to product identity for equals sine A cos C plus sine C cos A. Okay, so now, which means cos A sine C plus sine A cos C will be sine A plus C. So it means that we're going to have C squared parentheses sine A plus C divided by sine A sine C. Okay, now this is where we can now express C in terms of sine C. So we are using the same, we are using the same the same way we got B in this case. All right, so that means when we express, when we have to write C in terms of sine C, that will be, we're going to have C to be equals to 2R sine C. So which means C squared will be 4R squared sine squared C. So I'm going to what? I'm going to substitute 4R squared sine squared C for C squared. Then also we have here sine A plus C. Now, because we have here that sine A plus B equals to sine 180 minus C, which is equals sine C. So which means we can also solve for A plus C. We know that A plus C will be equals to 180 minus B. So which means sine A plus C, which is equals to sine 180 minus B, will be equals sine B. Okay, so now, so we can then write our C squared parentheses sine A plus C divided by sine A sine C, okay, to be equals to, so this will be 4R squared sine squared C multiplied by, so this will now reduce to sine B divided by sine A sine C. Okay, so now let's divide. Sine squared C divided by sine C. This will remain, what will be remaining here will be sine C. So this will be 4R squared sine C multiplied by sine B divided by what? Sine A. So we have our right hand side to be equals 4R squared sine B sine C divided by sine A. Now, and we got our left hand side to be, 4R squared sine B sine C divided by sine A. And here we have the right hand side to be equals to 4R squared sine B sine C divided by sine A. So now we can then conclude that the left hand side equals to the right hand side. So we just prove that in triangle ABC, B squared parenthesis cot A plus cot B equals C squared parenthesis cot A plus cot C. All true when we have this equation. That is when we have the left hand side to be equals this and the right hand side to be equals the same identity. And we've come to the end of this tutorial. The noblest pleasure is the joy of understanding. Bye-bye.